Okay. B6A1. What is gravitational field strength? So that is the strength of the gravitational field on, well, no, don't write that down, that's stupid. Okay, let me do this properly. No, let me try. I can do this. The force felt by a mass in a gravitational field at a particular distance from the center of the field. Or if you want it as a formula, G equals Gm over R squared. Don't know. I don't know. You are right, I agree with you, but is this the best for the exam? I don't know. What is the mass of the Earth? So, I don't know, I guess they must be expecting you to use this formula because that was the previous part. So we know what the G is. What's the G for Earth? The small g. 9.81. We know the big G. We know the radius. But this mass here is not the mass of the Earth. It's the mass of somebody on the Earth.
Really? Are you sure?
Yes. No.
No,
I'm sorry, guys. Don't listen to me. It's the mass of the Earth. Yes. Yeah. Yes. Sorry. Mass of the Earth. So what I'm going to do is rearrange this formula to get mass equals G(r) squared over G. So what's the small g? 9.81. The big G, 6.67 times 10 to the power of minus 11. And the distance, they say, is what? The radius. 6400 times 10 power 3. So when I put the numbers in, I will get an answer of 6.02 times 10 to the 24 kilograms. So this is 9.81, this is in the formula book, and this is given in the question, so it's okay. Right, part 3, what is the density? Density is mass over volume, which will be mass over 4 over 3 pi r cubed. You know the mass of the Earth? It should be pretty big. That's pretty big, alright. I got an answer of 5486 kilograms per meter cubed. Should be more than 1,000 because 1,000 is for water. Okay. Just 5 times? 5 times more? If your mass was 5 times bigger, would we say just 5 times more? Yeah. Determine the speed of the moon. Okay, so what they want is, they give you the time, is 27.3 days. And they give you the radius, is 3.84 times 10 to the 8. So, can I go down a bit? So what's happening here is the Earth, and here is the Moon, and they want to know the velocity here. Now This is a circular motion. If I remember the formulas for circular motion, you have omega V equals omega or. That's great because we know the or, but we don't know the omega. But what does omega equal? 2 pi over t. Do we know the t? Yeah. And do we know the or? We do. So we just need to change this into seconds, and we'll be fine. Is that okay, Abraham? Yeah. Okay. 27.3 days times 24 hours times 3,600 times 3.84 times 10 power 8. So if I put in all my numbers, I get 1023 meters per second. Okay. A spacecraft is put into an orbit around the moon. So there's the moon again, but here is my spaceship going around the moon. And the mass of the spaceship is, no, we want the time. Okay, and we know the distance here is 95 kilometers. And we know the radius of the moon is 1740 kilometers. And we know the mass of the moon is 7.18 times 10 to the 22. So with all this information, it seems like it shouldn't be a problem to work out the time. So I feel like Kepler maybe? Yeah? Well, let me see if I can have an idea. It's the only way I'll learn if I practice too. Okay.
I'm not sure my
That's okay. I know that for gravity, it's this formula. This is the mass of the moon, and we'll say M2 is the mass of the spaceship.
Do you know the mass?
We don't, but that's okay. And then we have F equals NA for the spaceship. This is the spaceship, 2 and 1. So if I make these equal, I get gm1m2 over r squared equals m2a.
What's the reading for the A?
Acceleration. Yeah. m2 and m2 cancel. So I get acceleration equals gm over r. Now I know the mass of the moon. It's given. And I know the radius. I just add these two numbers together. Do I have a formula for acceleration in circular motion? I do. In circular motion, you know that A equals omega squared or. So now I can make these equal. I get gm1 over r squared equals omega squared or. So I get gm1 over omega squared equals r cubed. So I get omega equals square root gm over r cubed. Now we don't want the omega, what do we want? Time. Yeah, but t equals 2 pi over omega, which will equal 2 pi root r cubed over gm. Finally, I can get the time because I know the m, I know the r. What's the radius? It's 1740 kilometers plus 95 kilometers over g. And then what's next? The mass, which is So when I put in all my numbers, I'll get 1.99 times 10 to the 13th. So nearly 2 10 to the 13th seconds. Do they want it in hours or anything?
No.
No, but I'm curious what it is in hours. No, that's not right.
That's right.
It's huge!
Yeah, I checked this. There's no.
This is the number you got?
The following is right. Let's see.
It is this big?
Yeah.
My goodness.
I used F because mg, and I found G first. G. And mg because m omega squared.
Now there is another formula you can use which we did in class, but it's not in the formula book. Which one? Let me see. Here it is, here. Well, that's one way of writing it. I want the one with just the m in it. Here. Now this formula is Kepler's formula. It's not in the formula book. Oh, for goodness sake.
Check it.
No, but I mean, this is Kepler's formula. Kepler's second law, I think, is it? Anyway, so notice that the formula looks the same as the one I worked out, except just rearranged slightly. So here in the formula you have a t squared. Yeah, it's the same. It's actually the same formula. But of course I had to go through a lot of trouble to find the formula. If you memorize this formula, you can use it for these problems. You might find them useful because, as you can see, it took me a little bit of work to get to the formula here. But of course, if you use Kepler's formula, you can get to it quicker. You can get t equals square root 4 pi squared or cubed over gm, which is 2 pi root or cubed over gm, which is what I have, isn't it? Yeah. I don't know why my answer's so big. It seems wrong. But you've got a big answer as well. Which is weird. So weird. Anyway, we'll go to the last part now for this. Yes, and we'll try and fit in the last question as well. Okay. Now, they want to know, here is the Earth, here is the Moon, and there's some place here where the forces from the Earth and the Moon cancel. There's two ways to do it. We can use Newton's GMM over r squared, or we can use gravitational strength. Which would you prefer? Which one? And which do you think? Huh? Okay. So what you can say is here, the gravitational field strength from the Earth is the same as the gravitational field strength from the Moon. They both cancel each other. Now what's the formula here? It's Gm for Earth over R1 squared. And here it's G mass of the Moon over, yeah, I'll just call it R2 for the moment. Yeah. Now that's nice because the G's cancel. So you can get R1 squared over R2 squared equals the mass of the Earth divided by the mass of the Moon. Now you know these because it's in the question. What was the mass of the Earth? Can you give it back to me, please?
7.18
Yeah.
times 10 to the 22.
Are you sure? Okay, and for the Moon it's...
6.
No, that's the mass of the Moon you just gave me.
Yeah.
I wanted the Earth.
Okay. Okay, the Earth is 6.024.
10 power,
24.
yeah?
Yeah.
Okay. So you have R1 squared over R2 squared equals 83.899. Because this is given in the question. You just, well, you divide them. Okay, what do you think I should do next?
When you find the ratio,
Yeah, what do I do?
you square it.
I'll use square root now. So I get R1 over R2 equals 9.16. 16. Yeah? So let's draw up, let's go back to my diagram here. So this is R1, and this here is R2. But in the question they call this X, so I'll put that in for X. And this distance here would be the total distance minus X. So you can say now that R minus X over X equals 9.16. So R minus X equals 9.16X. So R equals 10.16X. So X is R over 10.16. And the distance between the Earth and the Moon is in the question, isn't it? It's, it's radius of the orbit. 3.84 times 10 power 8 divided by 10.16. We have it. So if you want it as kilometers, it's 37,795 kilometers.
Sorry, but our is the orbital distance.
Yeah, it's 3.84 times 10 to the 8. It's the distance between the Earth and the Moon. Yeah, it's the orbit.
I didn't know the R, so I think it's impossible to convince.
Well, if you didn't know the R, it would be impossible. Yes, but you do know the R.